Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going through concentration in solutions, a topic which has both content for foundation and higher tier pupils. So please read the questions carefully in order to see if you need to be doing this topic. So without further ado, thank you to everyone who is subscribing to the channel. Please turn on all bell notifications, give the video a thumbs up, and let's grab a pen, grab a calculator, and let's go ahead and jump in. Okay then, so key content first of all. There are two different units for concentration, grams per decimeter cubed and moles per decimeter cubed. Now in questions you need to be able to identify what equation to use, and the way to do that is by finding the units for concentration. So they can either be grams per decimeter cubed or moles per decimeter cubed. Now 1 decimeter cubed equals 1000 centimeters cubed. So I'm just going to rewrite that up here. 1 decimeter cubed equals 1000 centimeters cubed. Now pupils often get this a little bit muddled up. Now if you ever struggle in an exam and you just can't think and have a bit of a brain freeze, just always bring it back to something you do know. So 1 kilogram equals 1000 grams. 1 kilojoule equals 1000 joules, and often they're the same conversion. And so if you had, I don't know, 285 centimeters cubed and you're thinking, I can't remember what that is in decimeters cubed, just think what you're doing. So you're going centimeters cubed, 2 decimeters cubed. So you're going centimeters, 2 decimeters. So therefore you need to divide by 1000 to get it into decimeters cubed, and so that's going to be 0.285 decimeters cubed. Now for your GCSE you also need to know how to change the concentration of a solution, and there are 3 ways to do that. You can either dilute by adding more water, or you can make more concentrated by adding more substance or evaporating some of the water. Okay, so the equation you need then is M equals C times V. Now, C stands for concentration. Now, as I said in the previous slide, this can either be grams per decimeter cubed or it can be moles per decimeter cubed. Now, this is why it's really important to read the question carefully, because if it's grams per decimeter cubed, your M is grams, and if it's moles per decimeter cubed, your M is moles. V is volume, and as we stated already, it always needs to be in decimeters cubed. However, it's often given in centimeters cubed, and you need to convert before putting it into the equation. Okay, so let's use this now in some questions. So feel free to either have a go at it, pause the video and see me go through the answer, or if you just want to take some notes for the moment and make sure you know how to do this, then you're more than welcome to do that as well. Calculators at the ready. Okay, so what is the mass of NaOH in 364 centimeters cubed of a 2.3 gram per decimeter cubed solution? So straight away I've got there grams per decimeter cubed, so I know I'm going to be using M equals C times V, and because my concentration is in grams per decimeter cubed, my M is going to be in grams. Then I'm going to take 364 and I'm going to divide that by 1000, and that's going to give me 0.364 decimeters cubed. Then I'm going to do M equals 2.3 times 0.364 equals, and when I do that on my calculator, that comes out at 0.84 grams. Really well done if you had a go at that and got that right. These are normally worth kind of like 2 to 3 marks, depending on how many things you have to do. Okay, next question. Ammonium chloride, NH4Cl, has a solubility 45 grams per 0.5 decimeters cubed at 25 degrees. How much water is needed to dissolve 76 grams of ammonium chloride? So first of all, we need to read this question carefully. So 45 grams per 0.5 decimeters cubed. So that means 45 times 2 equals 90. And that means that 90 grams is in 1 decimeter cubed. Now remember, the units for concentration are, I'm just going to rewrite that, 90 grams per decimeter cubed. And so the unit here is to 1 decimeter cubed. So because it's 45 to 0.5, it means it's 90 in a decimeter cubed. Now we've got our concentration. So what else do we need to work out? How much water is needed? So M equals C times V. And so how much water is needed, we're going to be working out our volume. So therefore, I'm going to do M divided by C equals V. I've got 76 there as a mass, and I've got my concentration of 90 equals, if I put that in my calculator down here, that gives me 0.84. Then I need to remember 0.84 what? Units of decimeter cubed, so it's 0.84 decimeters cubed. Really well done if you got that right. Okay, next. A solution of H2SO4 has a concentration of 2.3 moles per decimeter cubed. How many moles are in 237 centimeters cubed? Notice it's higher tier only now, please. So straight away, this is actually very, very similar to this question here. It's just the units are now moles. So what are we doing? I'm going to do M equals C times V. I'm going to take my volume, which is 237. Sorry, this is 237. I'm going to divide that by 1,000 to get it into decimeters cubed. So that's 0.237. I keep writing 6 for some reason. I don't know why. I'm just going to change that here. 0.237 decimeters cubed. There's my volume. I've got 2.3 moles per decimeter cubed. So therefore, M equals 2.3 times 0.237 equals, if I just stick this in my calculator down here, that comes out as 0.55 moles. Really well done if you got that right. Okay, a solution of H2SO4 has a concentration of 1.7 moles per decimeter cubed. How many grams are in 116 centimeters cubed? Okay, so this is where we really need to be paying attention to our units. So let's work this out. M equals C times V. I've got a volume here of 116 centimeters cubed, and I'm going to work this out as 0.116 decimeters cubed. Okay, so M equals my concentration 1.7 times 0.116 equals, stick this in, that comes out as, where are we? Just sort this out. 3, lovely. And that one comes out as 0.1972. And now we need to think carefully about our units. Moles, okay? Because your concentration here is moles per decimeter cubed. Now, what does it ask? It asks for grams. Okay, so now I've got to think, well, how do I convert moles to grams? So here, I've given the relative formula masses. So H2SO4, the MR of this is 98. And so if I now do 0.1972 moles times 98, comes out as 19.33 grams. Okay, and so here you need to be very, very careful. The question is asking for grams, but the units are moles, and so you need to use two equations here, because remember, moles times MR equals your mass. And so there are two equations that you need to be using in this question in order to work this out correctly. Really well done if you got that right. Okay, last one then. 27 grams of NaCl was dissolved in 876 centimeters cubed. What was the concentration of the solution in moles per decimeter cubed? Again, higher tier only. So, a couple of ways to do this. The first thing I'm going to notice, it's asking for moles per decimeter cubed, but it's giving 27 grams in 876 centimeters cubed. So first thing I'm going to do is I'm going to work out my moles. So how do I do that? Moles equals mass divided by MR. So I'm going to do 27 divided by 58.5, because when you do 23 plus 35.5, that's going to come out at 58.5. So I'm going to do that. 27 divided by 58.5. So that comes out as 0.461,538. There's a reoccurring there and a reoccurring there, and that's moles. Okay, now with these questions, the best way to try and tackle them is just think, right, I'm not sure what to do. What can I work out? And so I know I can work out my moles. So that's how many moles of NaCl I have. Now I know that I have that in 876 centimeters cubed. So what was the concentration? Now remember, concentration is always per decimeter cubed. And so M equals C times V then. So now I've got my moles of 0.461538 mole. I'm going to divide that because M over V equals C, and I'm going to divide that over the volume. Then I need to remember that's in centimeters cubed, so 876 divided by 1000 equals 0.876 decimeters cubed. And so there is 0.876 decimeters cubed. And when I do all of that, it comes out as 0.53. And then what are my units? Moles per decimeter cubed. Really well done if you got that right. Okay, so today then we've described what the concentration of a solution is. We've calculated the concentration of a solution when given the mass and volume, and we've explained how the concentration of a solution can be changed. Thank you very much for watching. Please do go through my other videos for more GCSE science content. And remember, if you ever need help with the GCSE, Dr. Kyle explains. Thanks very much. Bye-bye.